Did you know that Japan consumes over 120,000 tons of eel every single year? That's enough eel to circle the Earth nearly 3 times if laid end to end. But here's the shocking part. Almost 90% of these eels never see a natural river or ocean. They're born and raised in controlled aquaculture facilities that look more like high-tech laboratories than traditional fish farms. How do farmers transform tiny glass eels smaller than your pinky finger into the premium unagi that sells for over $60 per pound in Japanese restaurants? What cutting-edge technology makes it possible to raise millions of these mysterious creatures in artificial environments? And why has this ancient delicacy become one of the most sophisticated farming operations on Earth? Welcome to AgriCraft, where we dive deep into the world's most fascinating agricultural processes. I'm your host, and today we're taking you inside the remarkable world of eel farming, where tradition meets technology in ways that will blow your mind. From the moment these translucent baby eels arrive at the farm to the final processing stages that prepare them for global distribution, all will be revealed in this video. The story of eel farming begins with one of nature's most extraordinary migrations. For thousands of years, European and American eels have made an epic journey to the Sargasso Sea, a mysterious region in the North Atlantic where they spawn and die. Their offspring, called leptocephali, drift on ocean currents for up to 3 years before transforming into glass eels and swimming toward freshwater rivers. This incredible life cycle remained a mystery until the early 20th century, and even today, scientists still don't fully understand how eels navigate thousands of miles across open ocean. In Japan, eel consumption dates back over 4,000 years, with archaeological evidence showing that ancient communities along rivers and coasts regularly harvested wild eels. The tradition of eating unagi during the hottest days of summer, known as doyo no ushi no hai, began in the Edo period, when a marketing genius convinced people that the high protein content would help them survive the sweltering heat. Today, this single day accounts for nearly 20% of Japan's annual eel consumption, creating massive demand spikes that modern aquaculture must meet. But here's where the story takes a dramatic turn. Wild eel populations have plummeted by over 90% since the 1970s due to overfishing, habitat destruction, and climate change. The European eel is now critically endangered, and American eel populations continue declining rapidly. This ecological crisis forced the industry to turn to aquaculture, transforming eel farming from a small-scale operation into one of the most technologically advanced branches of modern agriculture. The global eel farming industry now produces over 300,000 tons annually, worth over $4 billion worldwide. China leads production with over 60% of global output, followed by Japan, Taiwan, and South Korea. But what makes eel farming so challenging is that, unlike other fish, eels cannot be bred in captivity on a commercial scale. Every single farmed eel begins life as a wild-caught glass eel, making this industry entirely dependent on natural reproduction cycles that humans still cannot replicate. The journey from glass eel to market-ready unagi begins at specialized collection stations along coastlines where these tiny, transparent creatures arrive after their ocean journey. Professional glass eel fishermen work during specific seasons, usually winter and early spring, using fine mesh nets and specialized traps to capture eels that are barely 3 inches long and weigh less than 1/3 of a gram. These delicate creatures are immediately transferred to temperature-controlled holding tanks where they undergo their first quality inspection. At modern eel farming facilities, the arrival of glass eels marks the beginning of an 18 to 24-month production cycle that requires precision timing and environmental control that rivals space technology. The initial stage takes place in nursery systems where thousands of glass eels are gradually acclimatized to their new environment. Water temperature must be maintained between 68 and 72 degrees Fahrenheit, with pH levels kept between 7 and 8.5. Any deviation can stress the young eels and dramatically reduce survival rates. The nursery tanks use recirculating aquaculture systems that filter and purify water continuously. Industrial machines monitor oxygen levels, ammonia concentrations, and water quality parameters 24 hours a day. Automated systems adjust water flow, temperature, and feeding schedules based on real-time data from sensors throughout the facility. This level of technological sophistication ensures that survival rates exceed 95% during the critical early months. Feeding glass eels presents unique challenges because they're transitioning from their larval diet to adult food sources. Initially, they receive specially formulated micropellets containing fish meal, soybean protein, vitamins, and minerals. The feeding process uses automated systems that distribute precise amounts of food multiple times daily, preventing waste that could contaminate water and cause disease outbreaks. As eels grow, their diet transitions to larger pellets with higher protein content, eventually reaching formulations that contain over 45% protein. After 3 to 4 months in nursery systems, eels are transferred to grow-out facilities where they'll spend the majority of their farming cycle. Modern eel farms use various production methods, from traditional pond systems to high-density recirculating systems that can produce over 100 pounds of eel per cubic meter of water. The most advanced facilities resemble high-tech manufacturing plants more than traditional farms, with computer-controlled environmental systems, automated feeding equipment, and sophisticated water treatment technology. The cultivation phase requires maintaining optimal growing conditions while managing the unique behavioral characteristics of eels. Unlike most fish, eels are primarily nocturnal and prefer to hide during daylight hours. Farming facilities accommodate this behavior with specially designed tanks that include hiding structures and maintain subdued lighting during day cycles. Water temperature is gradually increased to between 75 and 80 degrees Fahrenheit to accelerate growth rates, while dissolved oxygen levels are kept above 6 parts per million through continuous aeration systems. Quality control during the farming phase involves regular health monitoring, growth rate assessments, and water quality testing. Veterinary technicians conduct weekly health checks, examining eels for signs of disease, parasites, or stress indicators. Any abnormalities trigger immediate response protocols that may include adjusting environmental conditions, modifying feeding schedules, or administering therapeutic treatments under veterinary supervision. The farming cycle timing is critical because eels must reach specific size and weight targets to meet market demands. Premium unagi typically weighs between 7 and 10 ounces and measures 18 to 24 inches in length. Achieving these specifications requires carefully managed nutrition programs and environmental conditions that optimize growth while maintaining meat quality. Farmers track individual tank performance using data management systems that record feed conversion ratios, growth rates, and mortality statistics. As eels approach market size after 12 to 18 months of intensive cultivation, preparation for harvest begins with a process called purging. This critical step involves transferring eels to clean water systems and withholding food for several days to clear their digestive systems. The purging process ensures that the final product meets food safety standards and eliminates any off flavors that could result from residual feed in the intestinal tract. The harvest stage represents the culmination of months of careful management and technological precision. Unlike traditional fishing, eel harvesting from aquaculture systems requires specialized techniques that minimize stress and maintain product quality. Modern facilities use automated harvesting systems that gently remove eels from growing tanks using conveyor belts and specialized handling equipment designed to prevent injury to the delicate skin that's essential for premium unagi preparation. Timing the harvest requires coordination between farming operations and processing facilities because eels must be processed within hours of harvesting to maintain optimal quality. Harvesting typically occurs during cooler morning hours when eels are less active, reducing stress and improving handling efficiency. Automated systems sort eels by size and weight, directing them to appropriate processing lines based on their intended market destination. The transportation from farming facilities to processing plants uses specialized vehicles equipped with oxygenated water systems that maintain eels in optimal condition during transit. Temperature control during transportation is critical, with systems maintaining water temperature between 65 and 70 degrees Fahrenheit to keep eels calm and preserve meat quality. Live transport systems can maintain eel viability for up to 24 hours, allowing coordination between harvest timing and processing schedules. At the processing plant, eels undergo immediate quality inspection by trained technicians who evaluate size, appearance, and health indicators. This initial grading determines the processing pathway, with premium specimens destined for high-value markets like Japanese restaurants, while smaller or lower-grade eels may be processed for different applications. The grading process uses standardized criteria that consider length, weight, skin condition, and overall appearance. The primary processing stage begins with a procedure that must be handled with extreme care and precision. Eels are processed using traditional Japanese methods that have been refined over centuries, but now incorporate modern hygiene standards and food safety protocols. The process requires skilled technicians who complete each step in under 30 seconds to ensure optimal quality and minimize handling stress. Processing facilities maintain strict temperature control throughout all operations, with work areas kept between 40 and 50 degrees Fahrenheit to preserve meat quality and prevent bacterial growth. Industrial machines include specialized equipment for cleaning, filleting, and preparing eels according to different market specifications. Automated systems handle washing and initial cleaning stages, while skilled technicians complete the precise cutting and preparation steps that determine final product quality. The filleting process for unagi preparation involves removing the backbone while keeping the fillet intact, a technique that requires considerable skill and specialized knives designed specifically for eel processing. Modern processing plants combine traditional craftsmanship with contemporary food safety protocols, including sterilization of all cutting tools between each eel and continuous monitoring of work surface temperatures. Quality control during processing involves multiple inspection points where trained personnel evaluate each eel for defects, proper preparation, and adherence to size specifications. Any products that don't meet standards are diverted to alternative processing lines or removed from the premium product stream. This rigorous quality inspection ensures that only the finest specimens reach high-value markets. Following primary processing, eels undergo preparation for their final cooking stage, which varies depending on market destination. For traditional Japanese unagi, eels are typically grilled and glazed with a sweet soy-based sauce called tare. However, many processing facilities prepare eels for further cooking by restaurants or food service operations, requiring different preparation methods and packaging specifications. The cooking preparation process includes marination in specialized sauces that penetrate the meat and enhance flavor development during final preparation. Industrial machines can handle large volumes of eels simultaneously, ensuring consistent marination times and sauce distribution. Automated systems control timing, temperature, and sauce application rates to achieve standardized results across thousands of eels processed daily. Packaging operations for processed eels require specialized equipment designed to handle the unique characteristics of prepared eel products. Vacuum packaging systems remove air to extend shelf life while preserving texture and flavor. Temperature control during packaging is critical, with products maintained at near-freezing temperatures throughout the packaging process to prevent quality degradation. Modern packaging systems use automated equipment that portions eels according to market specifications, applies appropriate labeling, and seals packages using food-grade materials designed for frozen or refrigerated storage. The packaging process includes date coding, lot tracking, and quality assurance documentation that enables complete traceability from farm to consumer. Cold storage facilities at processing plants use sophisticated refrigeration systems that maintain products at optimal temperatures for different storage requirements. Fresh products destined for immediate distribution are held just above freezing, while products for longer-term storage or international shipping are flash frozen using industrial freezing systems that preserve texture and nutritional quality. Distribution from processing facilities involves complex logistics networks that coordinate timing between production schedules and market demand. Refrigerated transportation systems maintain proper temperatures throughout the distribution chain, while tracking systems provide real-time monitoring of product location and storage conditions. The distribution network includes both domestic and international channels, with specialized shipping methods for different market destinations. For international markets, eel products undergo additional processing and packaging modifications to meet importing country regulations and consumer preferences. Export facilities include specialized equipment for modified atmosphere packaging that extends shelf life for long-distance shipping. Documentation systems track all regulatory compliance requirements and provide the certification needed for international trade. The premium Japanese market represents the highest value destination for farmed eel, with strict quality standards that command premium prices. Products destined for Japan undergo additional quality inspections and specialized packaging that meets Japanese food safety and presentation standards. These high-value markets justify the significant investment in technology and quality control systems throughout the production chain. Domestic markets in eel-producing countries have developed different product formats and preparation methods that require alternative processing approaches. Value-added products include pre-cooked frozen portions, seasoned preparations, and convenience products designed for retail and food service markets. These products require different processing equipment and packaging systems, but utilize the same high-quality raw materials from aquaculture operations. The byproducts from eel processing create additional revenue streams that improve the overall economics of eel farming operations. Eel bones and trimmings are processed into fish meal that's used in aquaculture feeds, creating a circular system that reduces waste and provides valuable nutrients for other fish farming operations. Eel skin has applications in leather goods and traditional crafts, while oil extracted from processing waste has pharmaceutical and cosmetic applications. From a culinary perspective, farmed eel offers consistent quality and availability that wild-caught eels cannot match. The controlled diet and environment produce meat with optimal fat content and texture for traditional preparations. Professional chefs prefer farmed eel because of its predictable characteristics and year-round availability, enabling consistent menu offerings and standardized preparation methods. The nutritional profile of farmed eel makes it a valuable protein source with high levels of omega-3 fatty acids, vitamin A, and essential minerals. A typical serving provides over 25 grams of high-quality protein while delivering significant amounts of nutrients that support cardiovascular and neurological health. The controlled farming environment ensures consistent nutritional content and eliminates concerns about environmental contaminants that can affect wild-caught fish. Environmental considerations in modern eel farming have led to significant improvements in sustainability practices. Recirculating aquaculture systems reduce water consumption by over 90% compared to traditional flow-through systems. Waste management systems capture and treat all effluent before discharge, preventing environmental contamination and recovering valuable nutrients for other agricultural applications. Energy efficiency improvements in modern eel farming facilities include advanced heating systems that capture waste heat, LED lighting systems that reduce electrical consumption, and automated controls that optimize energy usage based on actual requirements. Solar power installations at many facilities provide renewable energy that reduces the carbon footprint of eel production operations. Research into eel breeding technology continues advancing toward the goal of closing the life cycle in captivity. Japanese researchers have successfully bred eels in laboratory conditions, but commercial-scale breeding remains technically and economically challenging. Breakthrough developments in breeding technology could revolutionize the industry by eliminating dependence on wild glass eel harvests and providing sustainable production methods. The integration of artificial intelligence and machine learning into eel farming operations is transforming management practices and improving production efficiency. Sensors throughout farming facilities collect data on water quality, fish behavior, and environmental conditions that AI systems analyze to optimize feeding schedules, predict health issues, and improve overall production outcomes. Automation technology in eel farming continues advancing with robotic systems that handle routine maintenance tasks, automated feeding systems that adjust to individual tank requirements, and computer vision systems that monitor eel health and growth rates. These technological advances reduce labor requirements while improving consistency and precision in farm management practices. The transformation of eel farming from traditional pond culture to high-tech aquaculture operations represents one of the most dramatic evolutions in modern agriculture. Today's eel farms combine ancient knowledge about eel biology and behavior with cutting-edge technology that monitors and controls every aspect of the production environment. This integration of tradition and innovation has created an industry capable of producing millions of eels annually, while maintaining the quality standards demanded by discerning consumers. The complete journey from glass eel collection to processed unagi, ready for consumer markets, demonstrates how modern agriculture can adapt to meet changing environmental conditions and market demands. The sophisticated technology, rigorous quality control, and comprehensive management systems used in eel farming provide a model for sustainable aquaculture development that other industries can adapt and implement. The economic impact of eel farming extends far beyond the farms themselves, supporting equipment manufacturers, feed producers, processing facilities, transportation companies, and countless restaurants and food service operations worldwide. This integrated supply chain creates employment opportunities and economic development in rural areas, while providing consumers with access to high-quality protein sources that would otherwise be unavailable due to declining wild populations. Looking toward the future, eel farming will continue evolving as new technologies emerge and environmental regulations become more stringent. Advances in recirculating aquaculture systems, renewable energy integration, and biological understanding of eel physiology will drive further improvements in efficiency and sustainability. The industry's ability to adapt and innovate ensures its continued role in global food security and cultural preservation. The remarkable story of how millions of eels are raised and processed reveals the incredible complexity and sophistication hidden behind what appears to be a simple agricultural product. From the mysterious life cycle that begins in the depths of the Sargasso Sea to the high-tech processing facilities that prepare unagi for global markets, every step requires precision, expertise, and respect for both tradition and innovation. This incredible transformation from tiny glass eels to premium unagi represents one of aquaculture's greatest success stories, demonstrating how modern farming technology can work in harmony with natural biological processes to create sustainable food production systems. The industry's continued growth and technological advancement ensure that future generations will be able to enjoy this ancient delicacy while supporting the livelihoods of thousands of farmers, processors, and workers throughout the global eel production chain. Thank you for joining us on this fascinating journey through the world of eel farming and processing. If you enjoyed learning about this incredible agricultural operation, please give this video a thumbs up and subscribe to AgriCraft for more in-depth explorations of how our food is produced. Leave a comment below and let us know what agricultural process you'd like us to investigate next. Until next time, keep exploring the amazing world of modern agriculture.